Welcome to this advanced Kotlin tutorial on bytecode inspection. In this video, you'll learn how to read and understand the bytecode that the Kotlin compiler generates. By mastering bytecode inspection, you'll be able to write more efficient and optimized Kotlin code. This skill is essential for understanding what happens under the hood when your Kotlin code runs on the Java virtual machine. Bytecode is an intermediate format that sits between your high-level Kotlin source code and the machine code that processors execute. It's a set of platform-independent instructions that the Java virtual machine can understand and execute. When you compile Kotlin code, the compiler translates it into .class files containing this bytecode. This allows Kotlin programs to run on any platform that has a Java virtual machine installed, making your code truly portable. There are several powerful tools available for inspecting bytecode. IntelliJ IDEA provides a built-in bytecode viewer accessible through Tools, Kotlin, Show Kotlin Bytecode. This is the easiest way to see what your Kotlin code compiles to. The javap command is a command line tool that comes with the Java development kit and can disassemble .class files directly from your terminal. For more advanced analysis and visualization, you can use the ASM Bytecode Viewer, which provides deeper insights into bytecode structure and behavior. Let's start with a simple example. Here we have a function called greet that takes a name parameter of type string and returns a string. The function returns a greeting message using string interpolation. This straightforward function will help us understand how Kotlin code translates into bytecode instructions. Even simple functions like this generate interesting bytecode that reveals how Kotlin handles string interpolation and function calls. When you inspect the bytecode, you'll encounter several key instructions. ALOAD loads a reference from a local variable onto the operand stack. LDC loads a constant value from the constant pool. INVOKEVIRTUAL invokes an instance method on an object. INVOKESBCIL is used for calling constructors or private methods. INVOKESTTIC invokes static methods. And ARETURN returns a reference value from a method. Understanding these instructions is fundamental to reading and interpreting bytecode effectively. By reading bytecode, you gain valuable insights into how Kotlin features work. You can see how null safety is implemented through automatic null checks that Kotlin adds to the compiled code. Inline functions reveal themselves by having their function body copied directly to the call site, eliminating function call overhead. Data classes show their auto-generated methods like equals, hashcode, and toString in the bytecode. Object declarations are implemented as the singleton pattern, ensuring only one instance exists. These insights help you understand the cost and behavior of different Kotlin features. Let's compare regular functions with inline functions. On the left, we have a regular function called process that takes a lambda parameter. When called, this creates a function object in memory. On the right, we have the same function marked with the inline keyword. When this inline version is called, the compiler copies the function body directly to where it's used, eliminating the overhead of creating a function object. This makes inline functions particularly useful for higher-order functions that are called frequently. Bytecode inspection reveals several optimization opportunities. First, use inline functions to eliminate lambda object allocation overhead, especially for frequently called higher-order functions. Second, avoid unnecessary allocations by identifying where the compiler creates extra objects that you might not expect. Third, regularly review the generated bytecode to check for unexpected method calls or boxing operations that could impact performance. By understanding the bytecode, you can make informed decisions about how to structure your code for optimal performance. One critical optimization involves understanding the difference between box types and primitives. When you use a generic list of int, each integer is boxed into an integer object, which creates memory overhead and is slower to access. However, when you use int_array, the integers are stored as primitive values without boxing. This results in better memory efficiency and faster performance. Bytecode inspection clearly shows these differences, helping you choose the right data structures for performance-critical code. By mastering bytecode inspection, you understand exactly what the compiler generates from your Kotlin code. This knowledge allows you to identify performance bottlenecks before they become problems in production. Most importantly, it enables you to write more efficient Kotlin code based on solid understanding rather than guesswork. Remember, great developers don't just write code that works, they write code that works efficiently. Bytecode inspection is your window into the true performance characteristics of your Kotlin applications. Thank you for watching, and happy coding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.